If you've ever wondered what your car could really do without restrictions, you're about to find out. The manufacturer left power on the table, restricted airflow, and programmed conservative limits to meet regulations. But what if you could unlock that hidden potential? Today, we're revealing 12 illegal modifications that deliver real performance gains most drivers never experience. These aren't just loud exhausts or flashy cosmetics. We're talking actual horsepower, better throttle response, and handling improvements that transform how your car drives. The final modification on this list is so powerful that some racing organizations have banned it entirely. Let's dive in. PCV System Delete, starting our countdown with a modification that's nearly invisible but surprisingly effective. Deleting your positive crankcase ventilation system removes restrictions that limit engine breathing while violating emissions regulations in every state. The PCV system recirculates crankcase vapors back through the intake to burn them cleanly. While environmentally responsible, this creates a restriction that limits airflow and introduces oil vapors that can cause carbon buildup in your intake manifold. A PCV delete typically involves installing a breather filter directly on the valve cover and blocking the PCV port. This eliminates the restriction and prevents oil vapors from contaminating your intake system. The result is cleaner combustion, reduced carbon buildup, and improved airflow. Performance gains are modest but measurable. Typically 3 to 5 horsepower on naturally aspirated engines and up to 10 horsepower on turbocharged applications where every bit of airflow matters. The modification also extends engine life by preventing oil vapor contamination of intercoolers and intake valves. The legal issue is straightforward. Any modification to emissions equipment violates federal law. However, PCV deletes are virtually undetectable during routine inspections unless someone specifically looks for the missing vacuum line. Installation costs under $50 for basic setups, making this one of the most cost-effective illegal modifications available. Just remember that you'll need to monitor oil levels more frequently since the engine will consume slightly more oil without the PCV system. Secondary air injection pump removal. This modification eliminates one of your engine's most power-robbing emissions devices while being nearly impossible to detect during casual inspections. Secondary air injection pumps force fresh air into the exhaust manifold during cold starts to help catalytic converters reach operating temperature faster. While effective for emissions compliance, these pumps create parasitic drag on your engine, and their complex vacuum systems often fail, triggering check engine lights. Removing the pump and its associated plumbing eliminates this parasitic load while simplifying your engine bay. The performance gain is immediate. You'll notice improved throttle response and slightly better fuel economy. The modification also eliminates the annoying pump noise during cold starts that many drivers find objectionable. Professional removal requires ECU tuning to prevent error codes, but the combination typically provides 5 to 8 horsepower gains depending on your engine. Turbocharged engines see larger benefits since the elimination of vacuum lines and pumps reduces the complexity of boost control systems. The legal risk is significant since secondary air injection is required emissions equipment under federal law. However, the modification is virtually undetectable unless inspectors specifically look for the missing pump, which is often hidden deep in the engine bay. Quality removal kits cost $200 to $400 and require professional tuning to prevent check engine lights. The modification pays for itself through improved reliability and performance, making it popular among enthusiasts willing to accept the legal risks. EGR system bypass. Exhaust gas recirculation systems reduce nitrogen oxide emissions by diluting combustion with inert exhaust gases, but they also reduce power and cause long-term reliability issues that make this modification attractive to performance enthusiasts. EGR systems recirculate exhaust gases back into the intake manifold to lower combustion temperatures and reduce NOx formation. While effective for emissions compliance, EGR EGR systems introduce hot, dirty exhaust gases that cause carbon buildup in intake manifolds and reduce engine efficiency. Bypassing the EGR system involves blocking the exhaust gas flow while maintaining the vacuum lines to prevent error codes. More sophisticated approaches use ECU tuning to completely disable EGR function while eliminating check engine lights. The performance benefits are substantial: cleaner intake manifolds, reduced carbon buildup, lower intake temperatures, and improved combustion efficiency. Most engines gain 8 to 15 horsepower from EGR elimination, with diesel engines seeing even larger improvements. The modification also improves long-term reliability by preventing carbon buildup that can cause intake valve sticking and premature wear. Many high-mileage engines run noticeably smoother after EGR elimination. Federal law prohibits tampering with EGR systems, making this modification illegal in all states. However, detection requires technical knowledge since EGR bypass can be accomplished without removing visible components. Professional EGR elimination costs $300 to $600, including tuning, making it one of the most cost-effective performance modifications available. The reliability improvements often offset the legal risks for enthusiasts with high-mileage vehicles. Crankcase ventilation system modification. Converting your engine's crankcase ventilation to a catch system eliminates oil vapor contamination while technically violating emissions regulations, but the performance and reliability benefits make this modification extremely popular. Factory crankcase ventilation systems route oil vapors back through the intake to burn them cleanly. However, these vapors cause carbon buildup in intake manifolds, contaminate intercoolers, and reduce octane ratings of the air-fuel mixture. Catch can systems intercept these vapors before they reach the intake manifold, condensing oil vapors in a separate container while allowing clean air to continue to the intake. The result is dramatically cleaner intake systems and improved combustion efficiency. The performance gains are particularly noticeable on direct injection engines, where oil vapor contamination causes severe carbon buildup on intake valves. Catch can systems prevent this buildup while improving throttle response and power delivery. Installation is relatively simple, but requires routing vacuum lines and mounting the catch can in an accessible location for regular emptying. Quality systems from manufacturers like Mishimoto or AOS cost $200 to $500 depending on complexity. The legal issue stems from modifying emissions equipment, even though catch can systems often improve overall emissions by promoting cleaner combustion. Most jurisdictions don't specifically prohibit catch cans, creating a gray area that many enthusiasts exploit. The modification is virtually undetectable during routine inspections and provides measurable benefits for engine longevity and performance, making it one of the most popular illegal modifications among knowledgeable enthusiasts. Throttle body spacer installation. Installing aftermarket throttle body spacers can improve airflow characteristics and power delivery, but modifications to intake systems technically violate federal emissions equipment tampering laws in most applications. Throttle body spacers create turbulence in the intake manifold that can improve fuel atomization and air distribution to individual cylinders. While the science is debated, properly designed spacers can provide measurable performance improvements on certain engines. The modification works by creating controlled turbulence that helps break up fuel droplets and improve mixture homogeneity. This can reduce knock tendency, improve throttle response, and provide modest power gains of 3 to 7 horsepower depending on the engine design. Installation is straightforward, requiring only basic hand tools and typically taking less than an hour. Quality spacers from manufacturers like BBK or Airaid cost $80 to $200 and include all necessary gaskets and hardware. The controversy stems from the legal classification of intake modifications. While throttle body spacers don't directly affect emissions equipment, they modify the intake tract in ways that could theoretically affect emissions compliance. The modification is completely reversible and virtually undetectable during routine inspections, making it popular among enthusiasts seeking easy performance improvements. However, the gains are modest compared to more aggressive modifications. systems. Professional installation ensures proper gasket sealing and torque specifications, preventing vacuum leaks that could trigger check engine lights. The modification works best on naturally aspirated engines with traditional intake manifold designs. Cold air intake with MAF relocation. Installing cold air intakes with relocated mass airflow sensors creates significant performance improvements, but violates federal tampering laws by modifying emissions-related sensors and intake systems. Factory air intake systems prioritize noise reduction and packaging constraints over maximum airflow. Cold air intakes relocate the air filter outside the hot engine bay while using larger diameter tubing to increase airflow capacity. The performance benefits are substantial. Cooler, denser air contains more oxygen, enabling better combustion and power production. Combined with reduced restriction, cold air intakes commonly provide 10 to 20 horsepower gains with proper tuning. The legal complications arise from mass airflow sensor modifications required for proper operation. MAF sensors measure incoming airflow for fuel injection calculations, and any relocation or recalibration technically violates federal emissions equipment laws. Installation complexity varies by vehicle, but most systems require 2 to 4 hours of work and basic mechanical skills. Quality systems from K&N, AEM, or InGen cost $250 to $500 and include all necessary hardware and instructions. The modification is easily detectable during visual inspection since it completely changes the appearance of the engine bay. However, many jurisdictions don't specifically target intake modifications during routine emissions testing. Performance gains increase with supporting modifications like exhaust systems and ECU tuning. Turbocharged engines see particularly dramatic improvements since cooler intake air reduces knock tendency and improves turbo efficiency. The controversy centers on off-road use only, labeling that manufacturers use to avoid legal liability while clearly designing products for street use. This legal fiction creates regulatory confusion that many enthusiasts exploit. Catalytic converter high-flow replacement. Installing high-flow catalytic converters can significantly improve exhaust flow while technically maintaining emissions equipment, but most aftermarket units don't meet federal efficiency standards, making them illegal for street use. Factory catalytic converters use dense honeycomb structures that create substantial exhaust restriction to maximize emission reduction efficiency. High-flow catalysts use less restrictive designs that improve power while still providing some emission control. The performance gains are impressive. Reduced back pressure allows engines to breathe more freely, typically providing 8 to 15 horsepower improvements. Turbocharged engines see even larger gains since reduced exhaust restriction allows turbos to spool faster. Quality high-flow catalysts from manufacturers like Random Technology or MagnaFlow cost $300 to $800 depending on application. Professional installation adds another $200 to $400, but ensures proper fitment and prevents exhaust leaks. The legal issue is complex. While high-flow catalysts aren't complete deletes, most aftermarket units don't meet the efficiency standards required for street use. Federal law requires catalysts to maintain specific conversion efficiency rates that most performance units can't achieve. Detection during emissions testing depends on local requirements. Visual inspections typically can't distinguish between factory and high-flow catalysts, but sophisticated testing equipment can detect reduced conversion efficiency. The modification provides a compromise between performance and legal compliance that many enthusiasts find acceptable. However, the legal risks remain significant in jurisdictions with strict emissions enforcement. Installation requires professional welding skills and proper safety equipment for handling exhaust systems. The modification works best as part of a complete exhaust system upgrade rather than a standalone improvement. Resonator delete systems. Removing exhaust resonators creates noticeable performance gains and aggressive sound characteristics, but violates noise ordinances in most areas while potentially affecting emissions compliance depending on local regulations. Resonators are designed to cancel specific frequency bands that create objectionable exhaust notes while maintaining acceptable noise levels. However, they also create back pressure that limits engine performance, particularly at high RPM. Resonator deletion involves replacing the resonator sections with straight pipe, eliminating the restriction and sound dampening. The result is improved exhaust flow, increased power output, and dramatically changed exhaust characteristics. Performance gains are typically modest, 3 to 8 horsepower, depending on the engine and existing exhaust design. However, the modification significantly improves throttle response and high RPM power delivery, where back pressure becomes most limiting. The sound changes are dramatic and often objectionable to neighbors and law enforcement. Resonator deletes typically increase exhaust volume by 10 to 15 decibels while changing the frequency characteristics in ways that many find annoying. Legal complications vary by jurisdiction, but most areas have noise ordinances that prohibit excessively loud vehicles. Some states also prohibit any modifications to factory exhaust systems, regardless of noise levels. Professional fabrication ensures proper pipe diameter and welding quality while maintaining exhaust system integrity. Costs range from $150 to $400, depending on complexity and local labor rates. The social responsibility aspect creates ongoing controversy within the automotive community. While the performance benefits are real, the noise pollution affects entire neighborhoods and contributes to restrictions on car enthusiast activities. Number 7. Fuel pump voltage booster installation. Installing fuel pump voltage boosters increases fuel delivery capacity and consistency, but bypasses factory fuel system safety controls in ways that violate federal motor vehicle safety standards. Factory fuel pump systems use voltage regulation to control pump speed and maintain consistent fuel pressure across different operating conditions. However, these systems often can't provide adequate fuel delivery for modified engines, particularly under high-demand conditions. Voltage boosters bypass the factory control systems to provide constant maximum voltage to fuel pumps, increasing their output capacity by 20 to 30%. This ensures consistent fuel delivery even during aggressive driving or with performance modifications. The performance benefits become apparent with engine modifications that increase fuel demand. Turbocharged engines particularly benefit since boost pressure can overwhelm factory fuel systems, causing dangerous lean conditions that can destroy engines. Installation is relatively simple, but requires electrical knowledge to properly integrate with factory wiring systems. Quality units from manufacturers like Kenny Bell or Snow Performance cost $150 to $300 and include detailed instructions. The legal issues stem from bypassing factory safety systems designed to prevent fuel pump failures from causing accidents. Federal motor vehicle safety standards require specific fuel system fail-safes that voltage boosters can override. The modification is virtually undetectable during routine inspection since it involves internal electrical changes rather than visible hardware modifications. However, the safety risks are real if fuel pumps fail at maximum output. Professional installation ensures proper wiring integration and maintains factory safety features where possible. The modification provides significant benefits for modified engines, but should be approached with caution on stock applications. Variable valve timing system. Elimination. Disabling variable valve timing systems simplifies engine operation while optimizing for high-performance applications, but violates emissions regulations since these systems are required for compliance across different operating conditions. Variable valve timing systems like Honda's VTEC, Toyota's VVTi, or BMW's VANOS change camshaft timing to optimize performance and emissions across different engine speeds. While effective for compliance, these systems add complexity and can limit peak performance potential. Elimination involves installing fixed timing components optimized for high-performance operation. The result is more consistent valve timing, simplified maintenance, and optimized power delivery for specific RPM ranges. Performance gains depend heavily on application and supporting modifications. Race engines see the largest benefits since consistent valve timing maximizes maximizes power output at high RPM, where variable systems often become limitations. The legal issues are significant since variable valve timing systems are required emissions equipment. Eliminating them increases NOx and hydrocarbon emissions beyond legal limits in most jurisdictions. Installation requires extensive mechanical knowledge and specialized tools for camshaft timing. Professional conversion costs $1,500 to $3,000 depending on complexity and can void warranties even if failures aren't directly related. Detection requires technical knowledge, making this modification relatively safe from casual inspection but vulnerable to dealership service departments. The complexity also means most enthusiasts avoid this modification unless building dedicated race engines. The controversy extends beyond legal issues to technical debates about whether the performance gains justify the complexity and cost for street-driven vehicles. Intercooler spray system. Installing intercooler spray systems dramatically improves turbocharged engine performance by reducing intake temperatures, but the systems often use methanol or other chemicals that violate emissions regulations when they enter the combustion chamber. Intercooler spray systems use water or water-methanol mixtures to cool intercoolers and reduce intake air temperatures. Lower intake temperatures increase air density and reduce knock tendency, allowing more aggressive tuning and higher boost levels. The performance benefits are substantial on turbocharged engines. Intake temperature reductions of 50 to 100 degrees Fahrenheit enable timing advance and boost increases that can provide 15 to 25% power improvements on properly tuned engines. Quality systems from manufacturers like Snow Performance or Devil's Own cost $400 to $800 and include pumps, controllers, nozzles, and mounting hardware. Professional installation and tuning are essential for safe operation. The legal complications arise when methanol injection systems are used, as methanol is considered a fuel additive that affects emissions compliance. Water-only systems avoid this issue but provide smaller performance benefits. Installation complexity requires mounting spray nozzles, running fluid lines, and integrating electronic controls with boost pressure signals. Proper tuning is critical to prevent over-injection that can cause engine damage. The modification is relatively difficult to detect during routine inspections since components are often hidden and systems can be temporarily disabled. However, the performance gains are so dramatic that many jurisdictions specifically target these systems. The controversy centers on the safety and reliability implications of introducing additional fluids into high-performance engines while operating in legally questionable territory. These 12 modifications prove that massive performance gains are possible when you remove the restrictions manufacturers build into our cars. From simple PCB deletes to complete engine management overhauls, each modification offers real performance benefits that transform how your vehicle drives. But remember, every single one of these modifications violates federal laws, state regulations, or local ordinances. We're not encouraging anyone to break the law. This information is purely educational, showing what's technically possible when regulations don't limit automotive performance. Which of these modifications surprised you the most? Drop your thoughts in the comments and smash that like button. And subscribe for more automotive content that goes beyond what everyone else is willing to discuss.